Hi guys, welcome again to our mikroC Pro for PIC tutorials for absolute beginner series. This is tutorial 82, part 2 of the Ethernet UDP-based control and monitoring. In part 1, we introduced the project. We also wrote the mikroC code and tested the project in simulation. In this part 2, we're gonna design the PC graphical user interface software. This video was sponsored by PCBWay, a Chinese-based PC board prototyping and assembly with great quality at low cost. As with other electronic design contests like Hack Day Prize, this year again PCBWay has launched the third PC board design contest where you stand a chance to win really big. They are offering over $5,000 in total prize and launch your product to market with them. All you need to do is to design your electronic product that uses a PC board and enter the competition and stand a chance to win. This is the timeline. The submission period began 25th of October 2019 and it's gonna end on the 25th of April 2020. So you still have time to submit your project, and here are some of the rules. You'll have to upload your entries in the PCBWay community and enter the keyword third PC board design contest. There is no limit to the design, so you can enter as many projects as you like. And here are the prize. The first winner is gonna win $1,000, including 10,000 PCBWay bins and startup service. Your product is gonna be selected to sell in the PCBWay Bazaar, which is an electronic marketplace. They're gonna be also the category of the most popular design. They're gonna be the second prize and the third prize as well. Here are some of the current entries. You can click on this view more to view the current participant, and to learn more about this contest you can visit this link to learn more. We're gonna create a C# application with Visual Studio. We are using Visual Studio 2019 community version, but you could also use any version of Visual Studio in this tutorial. If you don't have Visual Studio, you can download it from Microsoft website for free. Currently there are 3 versions. There is a community version which you can use for free. It says free for individual developers, academic users and open source. Or you could also buy the professional version or the enterprise version. In this tutorial we are using the community version, which is more than enough for individual developers and small team. We also use DevExpress component to design this thermometer gauge, this chart, this clock and this ribbon menu control, and also to change the skin of the application. These are DevExpress component. You can test their component for free for 30 days. You can download them from their website devexpress.com. But if you don't want to use a third-party component, it's okay. We're gonna design first with standard Visual Studio component that you get for free, test our code, then decorate the form with some few touch-ups using the DevExpress component. Let us start a new project in Visual Studio. Create a new project. It's gonna be a C# application. The language is gonna be C#. It's gonna be a Windows application, Windows desktop application. So this is the template that we're gonna use, WinForm app. It's gonna be a .NET framework application. Click next. You can give your project a meaningful name. We're gonna name it UDP PC GUI. We're gonna use the latest framework, which is 4.8. Select the location, select folder, create the project. The first thing, we're gonna create our menu. Gonna use the menu strip control. You're gonna also need the status bar. Use the status strip control. File menu. Connect, disconnect. You're gonna need also settings, and exit. This is gonna name it connect menu item, disconnect. Settings, then exit. To write the code, just double click. We're gonna start with the exit menu. Let us add some few namespace that we're gonna use. We're gonna need the system.net.socket, the system.net, and the system.threading. Let us declare also some few public variables. Public byte txt. This is the byte that is gonna hold the command that we're gonna send to our PIC microcontroller. In part 1 we said if we send a 0, it's gonna switch off the bulb relay and the motor relay. If we send a 1, it's gonna switch on the bulb, but if we send a 2, it's gonna switch on the motor relay. We're gonna initialize our UDP client. Let us create some settings as well, where we're gonna save our IP address in the settings of the application, so that even if we close the application, it's gonna keep our settings. Things like IP addresses and port number, we could save them in the settings. Settings, the first one is gonna be IP address. It's gonna be string. The scope is gonna be user. This is gonna be the microcontroller IP address. Make sure it's in the same range as your local network. The other thing, we're gonna need a port number. We're gonna use 10,001. Save. So now we can load our settings. We're gonna start with the IP address. Public string server IP address equals to properties .default.ip address. You're gonna need the port number as well. We're gonna convert it to int16. We're gonna also need a bool variable to check if our application is connected or not. Okay, when we click the exit menu, it's gonna close the application. Before we close the application, we have to close the socket if it's already open. So we're gonna say client.close, then environment.exit .exit code. The next thing, we're gonna code connect menu. With UDP is really simple. The first thing, we have to connect to a server. In this case, the server is gonna be our microcontroller. Then after we connect to the server, then we can start sending the UDP packet. So before we do anything, we have to make sure that the application is connected to the server. To do that, we're gonna say client socket.connect and specify the server address and port number. Server IP address, we're gonna read it from the settings. Then the server port number. Once we load our application, this disconnect is not gonna be visible. The visible property, we're gonna set it to false. So once we connect, we're gonna automatically set this to visible property to false. And the disconnect menu item, we're gonna set it to visible, so that we can be able to disconnect our application. It's gonna be true. The next thing, okay, I think for now we are fine. We can also set our boolean variable to true. Connected equals to true. When you are connecting to a remote server, there could be reasons when you're not gonna be able to connect. So instead of the application to crash, it's always good to manage the exception. So we're gonna use the try catch in case there is something that's preventing us to connect successfully to the server. Gonna snippets around with try catch. So when there is an exception, we're just gonna throw an exception, write a message, and we're gonna say error message, exception EX. Or we could just write failed to connect to the server, for example, instead of the application just crashing. So let us code the disconnect button. Gonna do the same, just copy and paste. We're gonna also handle the exception. Here we're not gonna connect, we are already connected. The first thing, the connect menu, we're gonna set it to true, and disconnect menu, we're gonna set it to false. connected is gonna be false. Then once we disconnect, if the motor was rotating or the light bulb was on, we need to switch off everything once we disconnect our application. So we're gonna send a packet to our PIC microcontroller. txt, we're gonna send a 0. We said if we send a 0 to the PIC microcontroller, it's gonna switch off everything. Client socket dot send. It's very simple to use UDP, and we just need to send the byte that we're gonna send. In this case, it's gonna be 0. So txt, and the size is gonna be 1. Once we connect our application, we can always write a status message, connected or disconnected. So in the status bar, let us add a label, a status label. Gonna name it connect. Once we load our application, the initial status is gonna be disconnected. Let's go to the connect menu. Once we are connected, you can just write text equals to connected. And if we are disconnected, we can also write disconnected. Great so far. What else? Okay, let us add some few buttons on our form. We're gonna need first some few group boxes. We're gonna need 2 groups. Group box, light bulb, and the display text is gonna be light bulb. Gonna do the same. This is gonna be the fan, box fan, and the display text we're just gonna write fan. Okay, we're gonna need 2 buttons for the light bulb. One is gonna display a background image of an off light bulb, and the other one is gonna be an on light bulb. Button light off. The appearance, the border style is gonna be 0, basically no border, and the flat style it's gonna be flat. The image, we're just gonna put an image of a light bulb. Import. The text, not gonna display anything. Can also increase the size of the button. Button light on, we're gonna do the same. So basically we're gonna put one on top of the other. When the button is switched on, this image is gonna come on and the other one is gonna be invisible. And once we disconnect it, we're gonna set the property of this one to invisible so that the off button can be visible. We're gonna do the same for the fan. The image, with the fan, we're gonna put a GIF image of a rotating fan. You can create your own, or you can just Google a GIF image of a fan. Okay. The off button, the image, we're just gonna put a static fan. Once the application starts, this button is gonna be invisible. False. The on button for the light bulb is gonna also be invisible. So we're just gonna see the off buttons. The last thing that we're gonna need for now is a component to display our temperature. We can use a track bar for now. Orientation, we're gonna set it to vertical. The maximum we're gonna set to 100, so you can display 0 to 100. The name we're gonna set track bar temperature. We can also need a label to display the current temperature. Label. Now name it label temp, and the initial text is gonna display 0 degrees Celsius. Let us make the text a little bit bigger. Calibri bold 26. properties. Great. Let us code our individual buttons. We're gonna need some few conditions to check if the button was already on before we can switch it on, or if it was off before we switch it off. If the light bulb is off, then this light bulb off button is gonna be visible and the light bulb on is gonna be invisible. So once we click on this button, it means we want to switch on the light bulb. And the first thing we're gonna check first, because if you wanna switch on the light bulb, we're gonna send a 1 to the microcontroller. But if this fan was already on, then we need to send a 3, because a 3 in binary is gonna switch on port D0 and port D1. So we're gonna check if motor on equals to true. Then we're gonna say client socket dot send. Gonna send our byte is gonna be txt, just gonna send 1 byte, it's gonna be 3. We're gonna send txt and 1. Then we're gonna make sure that this button is invisible. Dot visible equals to false, and the light button on, we're gonna set it to true. We're gonna set this light on variable to true as well. But if the motor was not on, then we just need to send a 1, not a 3. Next, we're gonna code the on button. If this one is visible, if we can click on it, it means we want to switch off the light bulb. We're gonna check first if the motor was on, then we need to send a 2, else we're gonna send a 0. Okay. We're gonna do the same with the fan, same principle. Once we load our application, we're gonna make sure that this group are not enabled, so that we cannot click any button before we connect to the server. So we're gonna set the property to false. The fan group as well, we're gonna set it to false. So once we connect, we can also set this property, the enable, to true. And once we disconnect, we can do the same. We can disable them. This is gonna be false. Okay, so far so good. What next? I think we're done with the send command. Then we're gonna be left the receive. This is gonna be on top of this, and this is gonna be on top of that, so that is not visible. Let us run our simulation. Run as well the software. Right, first thing, connect. Click the button, nothing's happening. The network is not connected. The button, okay, switch on. Press again, and switch off. The fan is rotating, and if I press it, it's gonna be off. So basically that part is finished. And if I click on disconnect, you can see the connect is not visible. If I click on disconnect, and it's gonna switch off the light bulb and the motor as well. Exit. Now the last part is to receive the temperature from the sensor. In the form load event, we're gonna start a new thread, because we can't receive on the same thread. It can end up freezing our application, because we are just waiting to receive something. So we need to receive on a different thread. Thread UDP server equals to new thread. Check for illegal cross thread, we're gonna set it to false. Then we're gonna start this new thread once the application load. Public void server thread, a public int temp. This is our temperature variable. UDP client Goes to UDP client, we're gonna receive on this port number. Whilst true, we're gonna check first if our application is connected. We're gonna need a try catch again so that we don't crash our application. Error, okay, let's say failed to connect to server. The value that we're gonna receive from the microcontroller is gonna be a floating point variable. So this is gonna be temp equals to float pass return data. We're gonna convert the byte to string. Then the track bar value is gonna be equals to this temperature value. Then we're gonna display that value to our text variable. Label temp is gonna be track bar value to string plus the degree Celsius symbol. If the temperature is between 0 and 30 degree, this text we're gonna display it in a green color. But if it's above 30 but below 45, below equals to 45, we're gonna display it in a yellow color. And if it's above, we're gonna display it in a red color. And that's all, guys. Let us run again. Run the simulation here. This is our form. The first thing we're gonna connect. Okay, it's reading already. We've got 13 degrees Celsius. Switch on the light bulb, switch on the fan. And what next? We're gonna change the temperature. Okay, let us increase the temperature. Remember, we've got a 2-second delay. The microcontroller is sending the data to the PC every 2 seconds. We can increase it to 26. After 2 seconds, it's gonna be updated. The track bar is going up and down and displaying the text. Let us go above 30, 33. It's in yellow. Let us go above 40, 45, let's set 49, it's gonna be in red. All right. Let us decrease again to, let's say, 17, it's gonna display 17. So basically that's all, guys. Everything is working perfectly the way we want it. You can switch off the fan, you can switch off the light bulb. And disconnect, exit. And that's all for this form. This is a basic form using the standard Windows controls. If you want to make it look a bit fancy, then you could use those Dev Express control that we use in this tutorial. So for the sake of time, we're not gonna go through everything. This is the applications. It's very simple. So instead of just using the normal menu strip button, Dev Express has got their own ribbon control. So you could just go to ribbon and drag the ribbon control. It's gonna drag this ribbon, or you can drag the status bar, which is gonna, this is the status bar. And the other thing, this is just a gauge, the gauge control. That's what we use for this thermometer and the clock as well. So this is just straightforward if you are familiar with the Dev Express controls. The source code of this project, you can download it from our website. I'm gonna put the link below the description of this video so you can go through the source code and see how we did it. Alright, so thank you guys for watching this tutorial. Don't forget to subscribe to this YouTube channel to receive more tutorials in the future. If you've got a question, if you've got a comment, you're welcome to leave it in the comment section. We always try our best to reply to each and every comment. If you've got a suggestion for future tutorials, you're also welcome. And I'll see you guys in the next tutorial. Thank you.